Here's our last section in chapter 4. We're starting to deal with arithmetic sequence. Okay, so again, this is an interesting thing. So sequences are when we can notice patterns that are happening in math. Like they give us a string of numbers and we can notice this commonality between them. We've already done this in one of the other sections where we were comparing x's and comparing y's and noticing this difference or this change that we kept seeing in our x's or our y's. And this is like further reinforcing this idea and this concept in this chapter. So arithmetic sequence is a sequence or an ordered list of numbers that form a pattern. Each number in the sequence is considered to be a term, an individual number. And as these start to go up, so you have like, let's say 1, 2, 3, 4, dot, 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 goes on and on and on. So that'd be 1, 2, 3, 4. I can already predict 5, 6, 7, 8, 9. They're changing by ones. So and we're going to use subscripts here. So like an exponent is a superscript, the little tiny number up above on the far right. This is a subscript. So it's a sub 1, meaning here's the first term in this sequence. So the first term is 1. The second term is 2. The third term is 3. The fourth term is 4. Should be a 4 right there. See if I fix that. Sorry, there we go. Let's make that 4. A sub 4. Dot, 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 to an unknown amount. We're going, who knows where we're going to? A sub n. N is the unknown term. We're going to always be trying to find that nth term, the unknown term. All right. So as we start to look at this, this is n, a sub n. This is our end term. We don't know where we're going to go. That's usually what they're going to be asking us to find as we start to do this stuff. Again, not heavy on the math here. There's a little formula we remember in this, and we are good to go. We can find, as long as you can find that pattern, see that common difference maybe between from one term to the next, you're good to go. So we need to look for the pattern, and we can see 3 things as we start to look at this, okay? As we start to look, let's see. See 3 common things. We have a common difference. A number is added over and over and over and over again, or maybe there's a common ratio, meaning there's some sort of multiplication going on over and over again, or there's just absolutely no pattern whatsoever. It's just random numbers that we can't find any kind of anything in coherency with it. In an arithmetic sequence, this is what we're doing. Think arithmetic, right? Arithmetic. Arithmetic means we are, what, adding or subtracting something. In an arithmetic sequence, we look for, our goal is a common difference, which means what's happening to this as you go from one to the next, to the next, to the next. They're adding or subtracting some common number between them all, right? So the easiest way to find our common difference is you'll take like a sub 2 minus a sub 1. Then you can take a sub 3 minus a sub 2. Test a couple of them. If you get the exact same number, you have what's called a common difference. So let's look at this. We have a sub 2 is 6. Okay, so we're going to say 6 minus 4.5, and we get 1.5. And then we're going to do a sub 3. So that was 7.5 minus 6. Again, we have 1.5. So we have a common difference here. Our common difference is 1.5. They're adding 1.5 to each way along the line, right? And if we wanted to predict, they gave us up to 4. What if we want to know what's the 5th? Okay, so we would take that 1.5 and we add it to 9. So our 5th term would be 10.5. And if we wanted to go to the sixth term, we'd take 10.5 and add 1.5. So add the common difference again, 1.5. And we would get 12. And we can do this over and over and over again. Notice, again, the difference here is 1.5. The difference between these two is 1.5. Difference between these two is 1.5. This is how we found those. We subtracted. We took 6 minus 4.5, 7.5 minus 6, 9 minus 7.5, and so on. And that's how we find our common difference. And then we can use that to keep predicting. Let's look at a counterexample. This is definitely arithmetic. What about this one? 3 and 9. Well, I can see what you subtract these two, that's 3. You subtract these two, 27 minus 9. Oh, that's 18. So there's definitely not going on. But what is happening to this? Can we figure this out? 3, 9, 27, 81. What if we were to take this? Let's take, instead of subtracting these, let's divide. We take 9 divided by 3, we get 3, right? 27 divided by 3 is 9. 81. Did I do that right? Nope, I didn't. $27 divided by 9 is 3. And 81 divided by 27 is also 3. So this is being multiplied by 3 each time, over and over. This is what they call a common ratio. There's a ratio happening here, a common ratio. That is not what we're looking for. We're looking in this chapter is to try to identify common differences that arithmetic. Is this arithmetic? No, it is not. It is a ratio. It has nothing to do with what we are looking for. There is a pattern, but it's not the one we're looking for. So why are we even doing all this? Because sometimes we may see this pattern, okay? And they want us to find a term like way down the line. Like if we're doing 2, 4, 6, 8, okay, obviously they're adding 2, adding 2, adding 2. It's easy to do 10, 12, 13, 14. But what if they wanted us to know, like, what is the 243rd term in that sequence? I don't want to count by 2's that high up, so we have a formula that can actually help us. Provided that we know our starting term and our common difference, we can go to any term they ask us to go to by using this explicit formula. The explicit formula for a sequence, okay? A sub n, it's any term, whatever term they want us to go to, like I just said, the 236th term. And if you start with 2, so a sub 1, what's the first term in the sequence? Would be 2. And our common difference was 2. And so then we plug in that 260 whatever here, minus 1, and away we go on our merry little way. Okay, that actually looks a lot like the word problem from our last set of notes, where there was the ride share problem. Let's see how this equation starts to work. So again, make sure you have a concept of this, that you know that this here is the n is the term they want you to go to. It's used here again in this equation. And we need to know what is the first term, and we need to find the common difference, because that's what we're plugging in. Okay, the term they want us to go to, the first term, and the common difference. This is where I have to swap my notes over because they've flipped on me. All right, so here is these terms here. We're going on. We have to see, is this arithmetic or is this not arithmetic? So again, we are trying to test this. We need to subtract these two and subtract these two. Do we get the same amount? 147 minus 21 is, this is 126. And then we take 1029 minus 147, and we get 882. This is definitely not arithmetic. And for fun, 147 divided by 21 is 7. When you divide them, you get a 7. 1029 divided by 147 is 7. So this is not arithmetic. It's not arithmetic. It's has a common ratio, not a common difference. So this is not an arithmetic sequence. This has a form of multiplication that's going on. Perfectly good to go. 28, 26, 24, 22. What's happening between these? Is it arithmetic, or is it that geometric where we're having some sort of common multiplication? Do we have a common difference, or is there a common ratio going on? Let's see. So if we take 26 minus 28, we get a -2. Oh, they're adding a negative this time. Now I can see it, right? They added -2. Then here, what did they do? They added a -2 again. Then here, what did they do? Oh, they added a -2. I can predict what, 20, 18, 16, and ... We could keep going, right? Let's see. What's the next two terms? Well, we did that here. Look at this one here. Again, what's happening here? What's happening here? What's happening here? Oh, 37 minus 34 is, they added 3 plus 3. What did they do here? They added 3 and they added 3. I want to know, what is the common difference? Well, it's just that, it's 3. They're adding a 3 each time. And they want us to figure out what is if a sub n equals, a sub n is 40, they want the 42nd term. So what we need to know is, what is a sub 1? So remember, I'll write it above. We need a sub 1. All right, our first term, which is 34. And let's refer to our equation up above. I know it's a little sideways. The first term plus n minus 1 times the common difference. Okay, so the first term, a sub 1, plus n minus 1 plus d, the common difference. Okay, so plus, we have 42 is n, minus 1, and the common difference was 3. We found all our pieces. Now we can evaluate. Order of operations is parentheses first. So 42 minus 1 is 41. And still in parentheses because we have another operation going on here. And then 41 times 3 is 123 plus 34. And then the last thing, add that 34. So the 42nd term in a row, if we kept doing this 42 times, we would end up with 157 as the 40th term. Let's see something more practical. A word problem, of course. You have a savings account that has your initial value, your starting point, $125. And you're going to add $39 each month. How much money will you have in 3 years? Okay, so 3 years is what? They want months. We have a conversion of units here. 3 years is, well, 12 plus 12 plus 12. That's 3 times 12. which is 36 months. Okay, so if we're writing our equation, we have an a sub n, so a sub 36. How much is in 36 months is going to equal our initial value, our first term, which is 125, plus n minus 1. So we have 36 minus 1 is 35. Times the common difference, the number that's being added each month, $39. So here we go. Let's start evaluating this. We need to do what? 39 times 35 first. Gives you 1365. And then you add to that the initial amount of money you started with. And you'll have, after 3 years of doing this, you'll have $1,490 in that bank account. I notice we kind of like solved it in reverse because of the room that we had here. But guys, this is all this sequence is. The arithmetic sequence allows you to find and predict numbers way down the line when you see these patterns forming. So all you really have to do is simply go in, you take a look, can you find it? Is it a common difference to start off with? Subtract the second term from the first and the third term from the second term. Do you have that commonality? And then from there, you can use your equation. It is the initial value plus wherever they want you to go to minus 1 times that common difference. Be careful, use your order of operations, evaluate it, and you'll be good to go. Get out there, guys, do your homework, and have a wonderful day.